Okay, now it's recording. Let me keep going with this lecture. Okay, now that was one example. So one example we just saw was this of a function. You know, again, it's telling you for how many days are in each month. So if that function f was a machine, we're putting the month into the machine, and the function is giving us back how many days are in that month. Okay, and we're just specifying our input and output using a table. There's actually many different ways to specify what a function is. One of them is with a table, as we have here. You could also write out in words what the function is doing. That's actually what we did in the example as well. You know, in the definition of f, we said what a function f actually does. You could use a table to define a function. I mean, the whole point is you want to say what the function does to each input. You could do that through a table. Another way is through a graph. Of course, in that case, you're working in the Cartesian plane. Excuse me. We're working in the Cartesian plane, you know, the XY plane where you graph stuff. You could use a graph to define a function. We will see that. And you could also use formulas. Generally, with a formula, you have x going into the function, and the function f is some algebraic expression like x plus 4 times 8, I don't know, something. But there's some kind of formula. So these are just different ways to define a function. A lot of you're going to see in this class using a formula. But you will have to deal with some graphs as well. Okay. But again, when I say a graph, I mean really a Cartesian plane, which is the XY plane, you know, the rectangular coordinate system. And that's what this represents. Remember, the idea is you have two copies of the real number line, right? One's horizontal, one's vertical. That's what these numbers tell you, they're numbers. The x-axis is horizontal. The y-axis is vertical. I mean, we'll see this later on, but the idea is you can plot points. Okay. We'll get to that later. I don't want to get too much into that now, but we'll see that later today. Okay, that's good. And this is just some terminology that the book does. I figured it'd be good if I do it. What's going to happen with these functions is if you're given an input and you give back the output, so in other words, you're getting the input from the corresponding input, that's what we call evaluating a function. So in that example with the month and days, you know, if you give me a month and then the function gives you back the number of days, we're evaluating that function. And you may also have to do this. Sometimes you don't know the input, but you want to find the output. Excuse me, but you're given the output. That's what we call solving an equation involving a function. In that case, in other words, you have the output, but you want the input. Sometimes you can get the input, sometimes you can't. Depends on the function. So again, let me say it again. When you have the input and you want to get the output, you're evaluating a function. When it's the other way around, that is when you have the output somehow, but you want the input, then you're solving an equation involving a function. Now, I'll be honest, not so much for the first term, but for the second terminology, I've only really seen it in this textbook. So, you know, but it still wouldn't hurt to know it. I mean, it's legitimate terminology. There's nothing wrong with it. I just haven't seen it used too much. So, but let's do another example. So again, here what I'm going to do is not there yet. We're defining a function, and I'm going to define it using a table. And that's what this is. And again, the idea is I'm taking each element for x, each input, and the function, here I'm using a table to specify how you get the output from the input. Right? So if your input is 1, by this table, we know the function is going to give us back 8. So if 1 goes into g, g is our function, 8 comes out, and so on for the other numbers. Notice the domain, which is all possible inputs, is the numbers in the top row. That's our domain. The range is all these numbers. That's what the range would be. Okay, so, for example, what would g of 3 be? Well, how do we get that? Let's go, again, we find 3 in the x row, because 3 is our input, and the table is telling us that g of x, so g of 3, is 9. So when x is 3, g of 3 is 9. And that's what this is saying. So we're evaluating the function, okay, g in this case, at 3. Okay, that's good. That was fun. Here's another one. What about g of 1? What would that be? Can anyone tell me? I might have typed it, but let me see. Yeah, 8. Looks like, yeah, someone said 8. Mr. Right. They said 8. And they're right, it's 8. Let me just get to that. And how do we know that? Because again, we have g of 1 here, correct? And when you plug it into 1, you get 8, as you can see. So g of 1 is 8. Okay, that's good. All right. Okay, so now those are examples of evaluating a function. Now, let's consider the other way. We're going to solve an equation involving a function. Although I really don't like that because we're not actually going to work with an equation. But here, what's going to happen is this. Now, we're going to say, what if the output is one of these numbers? Let's find the input. I mean, from a table as this, it's not so bad to do, because we have all the information we need in front of us. So if we want all x, so that g of x is 8. Well, we need all x such that g of x is 8. Well, looking at the table, this is all y values, right? So we want to know what x values give us 8. Well, we can see that 1 is an example. But is that the only one? Well, no. And how do I know that? Because we see 8 also over here. And 4 gives us 8 as well. So there's two solutions. When x is 1 and x is 4, g of x is 8. Notice it's still a function, because each input, each x value, is giving us only one output. When x is 1, we only get one output. X is 2, we're getting one output. With 3, we're only getting one output, and so on. Here, we're looking what values give us an output of 8. And in this case, there are two values. Still a function, though. All right, so that's one example. What about this one? We want all x so that g of x is 3. Okay, well, looking at the table, when is g of x equal to 3? Ah, here it is. So we have 2 as one value. Now, is there anything else? Not here. Remember, x is 3. We want to know when x is such that g of x is 3. So we're thinking of 3 as an output. Not here. Here we go. And what's x? 5. So it looks like when x is 2, when x is 5, we get 3 in either case. So there's only two solutions here. When x is 2 and when x is 5, in either case, g of x is 3. Okay, that's good. Now here's another example. What about this? When is g of x equal to 1? When is g of x equal to 1? Well, we have 1 here as x, but we want to know when 1 is g of x, when 1 is an output. Well, we have 8, 3, 9, 8, and 3. never get 1 back as output. We never get 1 back. In other words, 1 is not in the range. So there are no values. There are no solutions. You know, this is everything we have about the function. And nothing, there's no x value that when you plug in, g of that is 1. So there's no solutions to this equation. Okay, that was fun. Okay, what we're going to do now is we're going to do another example. This one's going to involve a formula. Okay? This one's going to involve a formula. Okay. Before I get to that, right, 5 is g of x equals 5. Right, someone else said something else. Okay, so now I'm going to keep going, but let me just pause this.